Okay, here's the solutions for page 12. Number 60 is the first problem on page 12. It lays out an entire situation here. A student can buy notebooks for 40 cents each and pens for 25 cents each. Notice that they've got the labels on all of these graphs as notebooks on the x-axis and pens on the y-axis. That is number of notebooks, number of pens. Ben needs to have at least 8 notebooks. Okay, so there's one inequality. Okay. Ben needs to have at least 8 notebooks. So notebooks, that's your x value. So that would be the inequality. X has to be at least 8. So that's one inequality. Okay? Now think about the graph of that. X equals 8 is a vertical line through 8. Notice that all 4 graphs have a vertical line through 8. Now right there, we have enough information to actually answer this problem. We don't even have to consider the other inequality, because this says x is greater than or equal to 8, which means we have a solid line, meaning that we can eliminate the first answer because it has a dotted vertical line. And we can, for this exact same reason, eliminate D. This is not a solid line. The other thing that tells us right away is if x is greater than or equal to, we would be shading above that, which, since it's a vertical line, would be to the right. Which means, of the two remaining, this cannot be correct because we shaded to the left. So C has to be the correct answer. There's really no reason to kill any more time with this problem. Number 61 says use elimination method to solve this system of equations, which is fine. That's how I would have done it anyway. I look at this and I see that the y's have different signs, but they are not the same number. And I would start off by multiplying everything in the first equation by 3. The reason I'm choosing 3 is because 3 times negative 2 would give me a negative 6 here. And that would allow the y's to eliminate. So when I do that, my new system becomes 15x minus 6y equals negative 30 is the new first equation. And the second equation remains exactly the same. So then I add those equations together. The y drops out. And I get 18x equals 36. Divide by 18. And I get x equals 2. Okay, now I just need to plug that in and find y. So I say, okay, if x equals 2, then 3 times 2 plus 6y is 66. So everybody should see that I took that x and I plugged it into the second equation. Doesn't matter, you can plug it into the first equation, you get exactly the same thing. 3 times 2 is 6, plus 6y equals 66. Now, there's a lot of things you could do, but that's really just a two-step equation. So subtract 6 from each side, which would give you 6y equals 60, and then divide by 6, which would give you y equals 10. So, we have y equals 10 and x equals 2. We're supposed to write that as a 0.26 would be the answer we would provide for this problem. Number 62 says use elimination again. All right, no problem. Again, when we're deciding, it doesn't really matter what variable we eliminate, but I would eliminate y again here, because when I'm looking at this, to get 7 and 5 to be the same number, I would have to multiply both equations. But to get 8 and 4 to be the same number, I only have to multiply the first equation. So I would multiply the first equation by negative 2. Everything there by negative 2. That would give me negative 14x minus 8y equals 8 for the first equation, and 5x plus 8y equals 28 for the second equation. I would then add those equations together. Y would drop out, and I would be left with negative 9x equals, and this would be what, 36? Divide by negative 9. And we get x equals 4, which is half of our answer. Now there are 2 variables in this problem, so we do need to find the other variable. So let's take that 4 and let's plug it in for x in the second equation. 5 times 4 plus 8y equals 28. That would be 20 plus 8y equals 28. We would subtract 20 from each side, which would give us 8y equals 8. And then divide by 8 to get y by itself. And we would get that y equals 1. So again, we take those two, we write it as a point, x, y, 4, 1 would be the answer that we would provide. Okay, number 63, again, says use elimination. This is almost the last problem. I guess it's not quite the last problem. Now, this is one where we can't get away with only multiplying one equation. So again, we have to make a decision. We're going to eliminate x, we're going to eliminate y. And I look at this and I would eliminate y because the signs are already different. So the least common multiple of 4 and 3 would be 12. It means I need to multiply the first equation by 3 and the second equation by 4. That would change this system into 6x minus 12y equals negative 66, and 12x plus 12y equals 120. When I'm now set up for elimination, because when I add them together, the y will cancel. That gives me 18x equals what? 54? Yep, 54. I would then divide by 18, and I would get that x equals 3. Then I have to find out what y equals. So again, I'm going to take that x and I'm going to plug it in up here. It doesn't even matter which of these 4 equations we use, but I'm going to use this bottom one, 3x plus 3y equals 30. So 3x would be 3 times 3 plus 3y equals 30. That would be 9 plus 3y equals 30. Subtract 9 from each side would give me 3y equals 21. And then divide by 3, which would give me y equals 7. X is 3, y is 7. My answer is the point 37, because that is how we present answers to naked substitution or elimination problems. Okay, last problem on this page is number 64. It is a system of equations word problem. It says the admission fee of a theater is $2.50 for adults and $1.25 for children. On a certain day, 700 people went to the theater for a concert and $1,375 was collected. They want us to tell them how many children and how many adults attended the concert. So we're going to let X represent the number of adult tickets. And we are going to let Y represent the number of child tickets. I said before we didn't technically have to state this because it didn't tell us to, but it's a good habit to get into because on the I step they're going to tell you to. And it'll lose a point if you don't. So it's a good habit to get into. X is going to be the number of adult tickets and Y is going to be the number of child tickets. Now you'll notice that they told us how many people attended the concert, 700. So your first equation is X plus Y is 700 because all 700 people would have needed a ticket to get in. The other information in the problem is price, $2.50 for adults, $1.25 for children, a total of $1,375. So we're going to say 2.5x plus 1.25y equals 1,375. Now again, we're trying to eliminate here, and the fact that there are decimals in this problem changes nothing. We need one of these two variables to match up and eliminate. So what I'm going to do is I'm going to multiply the first equation by 1.25. And I know that that seems like an odd number, but it'll be okay. I'm actually going to use negative 1.25. So that my y's will cancel. So that will give me negative 1.25x minus 1.25y equals, and this one I do actually have to pull out my calculator for, 700 times negative 1.25 is negative 875. Second equation is unchanged. 2.5x plus 1.25y equals 1,375. So if you notice, the y's will now cancel. So I add these equations together, which would give me 1.25x equals, and then I would subtract 1375 minus 875 and get 500. I would then divide each side by 1.25, and that would give me that x equals 400. So if x is 400, then we can plug that back into this first equation, x plus y. So 400 plus y equals 700. And subtract 400 from each side to get that y is 300. So what does that tell us? Well, we have to answer with words. It says how many children and how many adults. So x was the number of adults. So there were 400 adults and 300 children attended the concert. Okay, that does it for page 12.